Welcome back to my channel, guys. If you haven't subscribed yet, go ahead and do that. It's Silas Tutoring Center. Silas Tutoring Center for my YouTube channel. That's where you can find all my videos. I have a Facebook too, but for right now, you can find all the videos on my YouTube channel. Okay, thank you for watching. If you already have been watching my videos, and thank you for liking or commenting, and anything you do is helping me out. Thank you so much. So today we're gonna study the behavior of function. We're going to study the polynomial of degree 1 today. So we're gonna study a polynomials behavior. So what we're gonna do is we're going to find out the behavior of a graph, the function the graph is going to be even before we graph the function. So what I mean by that is when someone tells us a function, we should be able to figure out which way the function is going to behave before we exactly solve for y and x and intercept and all that, to figure out how the intercept is going, where the intercept is going to be, and how the function is going to behave. We should be able to see that right through the function as soon as we have the function. So the first one we're gonna do today for this video, in this video we're going to do the polynomial of degree 1. A polynomial of degree 1, let's say polynomial is the general term for all the function that is on the axn plus bxn minus 1 plus that plus zx to the plus, let's call this y plus n, for example. Okay, so it's gonna present to this form: ax squared plus bx plus c, ax cubed plus bx squared plus cx plus d, ax to the fourth plus bx to the cube plus cx squared plus dx plus e, etc., etc. So we call all of them polynomial. But today we're going to figure out the behavior of the polynomial of degree 1, which is ax plus b. That's the polynomial of degree 1. So a polynomial of degree 1, we call it a line, basically. A polynomial of degree 1 is called a line, and it's always in this form. I can call it f of x. I can call it y, and it's always in this form, ax plus b. So the way to figure out this polynomial is we have the x-axis and the y-axis this way. So there is only 4 ways a line can behave. It's either this, in this quadrant, it's either in the first quadrant, either in the second quadrant, either in the third quadrant, and either in the fourth quadrant. Okay, so I would say 6 ways, but the other 2 are the 2 basic ways. It's like exactly in the center of the right here. At the center, we can say this line, we know this y, this is for y is equal to x. So when x is going up, y is also going up. And for the opposite one, that's for y equal to negative x or x equal to negative y. That's the same thing. Okay, so x equal to negative y or y equal to negative x, that's the same thing. So that's exactly at the center. After that, there's only 4 ways a polynomial can behave. It's either this way, first quadrant. It's either it's in the second quadrant, the third quadrant, or the fourth quadrant. Okay? It all depends of the behavior of these two numbers. It's all depend of these two numbers. It's depend of, is this number negative or positive? Is this number negative or positive? So with you guys, I'm going to show you how to figure it out, how to figure out the behavior of the graph. I'm not gonna just tell you which way it's going to be. Let's just do it together. Okay, I'm gonna show you how we figure it out. Okay, so let's say for example we have y equal to 2x plus 3. And they tell you what is the behavior of this line. You don't know it because you didn't do it yet. So this is a line. The easiest way to figure out the behavior is just to let x equal to 0 and y equal to 0. When x equal to 0, here you have y equal to 3. When y equal to 0, we have x equal to negative 3 halves. So I said for this line, x is negative 3 halves and y is 3. And I said, okay, if I'm drawing a line, to draw a line, you only need 2 points. That's all you need to draw a line, 2 points. Okay, so that's this way. What if it was negative 2x? Look that my y value would still be 3 when x is equal to 0. When x is equal to 0, this value doesn't matter because when you multiply by 0 is 0. So my y is still 3. But what's going to be my x value when y equal to 0? My x value would be 3 halves. So it's going to be positive. 3 halves somewhere around here. I said, oh, okay, that's my, this one was y equal to 2x plus 3. So this one equal to y is equal to negative 2x plus 3. So now let's say we already figure out for positive or negative b. Now let's figure out for positive and negative y. A. When a is negative, y is gonna be in this. Y is gonna be negative. So let's say y is equal to negative 2x plus 3, for example. So what is gonna be my x and y value when we let each other equal to 0? At x equal to 0, I'm sorry, I said we already let a equal to 0. That's the one we solved for these two. So now we're gonna let b equal to, we already let a be a negative number. When we let a be negative, we see that we have the behavior like this. For positive, we have this behavior. So now we're gonna let b positive and negative. We're gonna do it for b positive and negative while a is negative, to see what's going to happen for the graph. So if a is negative, if we let b negative, so at y equal to 0, our x is gonna be what? It's gonna be 3 halves. But when x is 0, our y would be what? It's gonna be negative 3. It's gonna be negative 3. You see that? Okay, so what we see from that is if our b value is negative, we know that our function is going to behave in the negative part of the y. Okay, so when y is 0, now x is going to be what? Y is 0. Negative, negative, x is going to be negative 3 halves. is gonna be from here. Okay, I have y equal to negative 2x, negative 3. And the other one would be, without doing it, it will be y equal to negative 2x minus 3. That's the one we don't have. So, I'm sure if you do this, if you let y equal to 0, x equal to 0, you can figure out this function too. You can figure out it's going to be in this quadrant. So, what we can see from that is we only need to know what's the value of a and b to find the behavior of a line. Okay? We see that if both a and b are positive, okay, my line is going to be in the second quadrant. Here. Okay? And I said if my a positive and my b negative, I'm gonna, like if I have y equal to ax minus b, my graph is gonna be in the fourth quadrant. If I have y equal to minus ax minus b, my line is gonna be in the third quadrant. And if I have y equal to minus ax plus b, my line is in the first quadrant. You see? Minus ax plus b, first quadrant. Ax plus b. Minus ax plus b. Minus ax plus b, first quadrant. Minus ax plus b, first quadrant. Ax plus b, second quadrant. Minus ax minus b, third quadrant. Ax minus b, fourth quadrant. So that's all we need to know. Ax plus b, minus ax minus b, ax minus b, minus ax plus b. That's all. So that's how you draw a line. That's how you know the behavior of a line before you even trying to know the number, the intercept. The intercept. Let's say if we go to a test and you need to do that very quick, you don't need the numbers, you just need the behavior. They tell you, they ask you, can you draw this line without telling us what the intercept is? And you say, oh, I remember, oh, it's going to be in the first quadrant. I say, okay, it's going to be like this. That's the behavior. You say y, x. You can figure out this later. If you go, like if you're choosing the y inches and you see all the other graph doesn't behave in the first quadrant and you see this one behave in the first quadrant, before you find out what is the intercept, you can choose this intercept because you know that the behavior is going to be exactly in the first quadrant. Okay guys, that's all I'm gonna say about this video. So I'll catch you later for another video. I'm gonna do the polynomial with 2 degrees, which is a trinomial, and I'm going also to do the behavior for 3 degrees, and I'm going to do for trig functions and everything. So let's keep in touch, and I'll see you in another video. Peace.